Morning, everyone. Begin to from Nephos Technologies. Hope everyone's well. Thanks for joining. I know some of you are waiting for us to join, but we're here now, which is great. Just wanted to give the last few guys a chance to turn up. And I can see that we've got someone just coming in now, so that should be them. Couple of quick housekeeping items. It's a short 30-minute webinar today, introducing you to Cloudian object storage and to Nephos Technologies. If you could remain on mute, that'd be great. Any questions that you might have, ping them through on the chat, and we'll pick them up at the end of the webinar. We'll try and carve out 5 minutes at the end to clear through some of those. So, as a start point, just to introduce you into Nephos Technologies and who we are, Nephos as a business are a UK-based organisation that designed and delivered what we would term next-generation data centre infrastructure. And we do that with some core tenets in mind, or some core principles in mind. As a business, we're a cloud-first organisation, so we focus very much on what we call next-generation technology sets. So software-defined, hardware-agnostic, cloud-integrated technology sets, typically built API up, focused on that infrastructure stack. So not Office 365 or Google Docs or those wonderful things, cloud storage, DR, compute, those sorts of environments. We do that independently, in as much as we deliberately haven't developed our own data full of service offering. We don't believe that's the way organisers want to consume their infrastructure, nor do we believe that it's the right way to go commercially when you consider the likes of these new software-defined technology sets that can deliver cloud economics in your own data centre. And we're also proven, you'll see here some of our core customers, across multiple different organisations in multiple different sectors. The one thing that keeps all of them in common really is data. We are in a data-driven world, and ultimately what we need from our infrastructure is fundamentally changed. And what we mean by this is that, if you consider the amount of data that's being bought, sold, generated on a daily basis, traditional infrastructure is unable to cope with that scale. And that's what we're going to look at today. We're going to look at how we cope with that scale with large-scale object storage from Cloudian. To set the scene a little, and this probably won't be a surprise to anyone, that digital universe is changing. 90% of all the data being generated over the next decade is likely to be unstructured. That data that is being generated is ultimately more valuable, particularly if you consider the use of big data analytics, platforms like Spark and Hadoop, these sorts of technology sets that are really driving business change and enabling people to streamline operations, drive more value from their data. I guess if you go back 10 years, you sat on a pile of data that you continued to sit on for a number of years that didn't really do a lot. We're now realising that actually if we analyse that infrastructure and that data, that we can drive value from it. If it's more valuable, naturally it needs to be more protected. It makes sense. What we're also seeing is that traditional infrastructure is pretty inefficient in the way that it works. Now, this 500% number seems excessive, but you'll see coming up in the following slides that it's not. Ultimately, for every terabyte of storage you need, you'll buy at least 5 terabytes. Again, commercially not sustainable, makes it much trickier to manage, particularly as you scale that environment. And we also see that there's a huge increase in overheads for management of that storage infrastructure. It's the age-old problem that IT never has any more budget than they had last year, and they don't have any more people, but they do have twice as much to manage. And it's that old adage. When we look at traditional storage, we see a number of challenges. The first one I'm going to touch on is all around silos and complexity. This is one of the contributing factors to you storing 5 times more data than you require. Now, this won't look, I have no doubt, will look like most of your environments. There will be some core storage infrastructure in place, you know, whether it's NAS, SAN, from the likes of NetApp or EMC, whatever that might be, there will be primary storage there. You'll typically replicate that, maybe locally replicated, and then geo-redundant replication also, to give you that belt and braces for DR. And that forms the core. If you look to the left, we've then got this whole massive backup environment that we need to manage. On top of that, you know, your backup software, disk to disk, backup to disk platforms like Data Domain, off to tape, and then, you know, the man in the van with from Iron Mountain or whoever it may be that you use to go and take that data away and long-term archive it. We have the challenge of mobile access. How do we give access to our users across multiple locations from mobile devices, and how do we do that in a secure way? And that remote location aspect is a particular challenge in distributed environments where actually businesses want to collaborate more. We see it more and more with our customers that, you know, it's no longer one siloed group of people in one office working on a project. Data needs to be shared across the environment. And how do you do that today? Well, you leverage replication, things like DFS, DFSR. You know, organizations are buying WAN acceleration, WAN optimization technology sets to overcome some of the hurdle of moving that data around. It becomes very costly and very complex, and you end up with lots of different silos of data. As you can imagine, if you consider your primary storage environment geo-redundant, backup, plus what's replicated across multiple sites, that's 4 or 5x the storage footprint in and of itself. So you can see how that can mount up. The other thing that we see in the market is that there's a shift between this sort of performance versus capacity requirement. If you go back in time, you would have either bought some NAS infrastructure from the likes of NetApp, very good at file data, not great at virtualized workloads, or you would have bought some quite expensive SAN infrastructure, you know, whether it's a VNX or a VMAX or whatever it might be from EMC. Great for high performance workloads where you need I/O, but that's not really where you want to put your file data, where you want to put your data, which is where the bulk of that growth is. And we see that shift towards unstructured data, partially because applications are moving to SaaS. You know, you look at Office 365, Google Docs, all of those sorts of things. You know, there's a change there in terms of the virtual workloads. And these things have different requirements. So in our mind, what we need to do is create a 2-tier architecture. And that 2-tier architecture is typically, if you look at the grey block, that's your block environment. That's the sort of growth that we see. So right now, the number of virtual machines that most people have isn't necessarily growing in number, but they are growing in density, performance density. So people are trying to drive more out of the virtual machines they've got. But as you can see, that huge growth area is unstructured, this file. And there's some changes in the way people are using that file data as well. You know, if you look at those environments, data can be stored, not read, quite common. You know, for most of our customers, when we look at their file environment, 20 to 30% of that data set will be hot. The rest will be archived for all intents and purposes. The difference is what people want from that archive is now that they want it to be active. You know, it's no longer good enough to put that data on tape and then give it to Iron Mountain and take 4 days for it to bring back. If you're holding bigger pools of data and you're looking to run analytics on it, you're going to run that analytics on a per job basis, and whilst you might not use it all the time, you do want it back in a timely manner, and that behavior is changing. So in our mind, we create a 2-tier model. We create a performance environment, which would be traditionally where your SAN sits, using converged or flash, or maybe infrastructure as a service from the likes of Azure and AWS. And then we create a capacity environment, and that's what we're looking at today. That capacity environment for us is always based on objects. We leverage object storage. or cloud storage, as you could refer to it as. Now, whether that's public cloud or private cloud, the model is the same. Ultimately, it is software-defined storage on x86 hardware. It gives you lower cost, higher capacity, easier scale, and in our model, what we do is we centralize that data into one object store across multiple use cases. If you look at the data center model below, this is the model we're driving at. So traditionally, where you've got that sort of cross-site replication, etc., backup environment, disk-based backup, our model's different. The first thing we look to do is effectively take the file infrastructure off of that SAN NAS environment, and we push that into an object store. We leverage distributed Erosion Coding, which I'll come on to, across multiple sites to give us high availability, high durability of data. Once that platform's in place, we're then in a position to support multiple different use cases. So the first thing that we usually look to do is consolidate our backup infrastructure. For us, we work with Rubrik to effectively collapse down that tier, push archived backups out into the object store over an S3 interface to reduce footprint and cost there. We then look at that SAN NAS environment and we leverage either hyperconverged or all flash or cloud infrastructure for the compute-based storage where you normally have your SAN. And then we leverage cloud storage gateways in effect to push our file data and our working set into that same object store and replace the requirement for remote office NAS. We centralize all of that storage into the object store. We create a global file system. We enable file locking. If you want to use it, we remove the need for all of that remote office backup and consolidate all of that down into the same object storage tier. Now, as you can imagine, whilst it's a simplified diagram, there is a huge cost benefit. There is a huge management overhead benefit to taking that approach. The key to it is object, and that's what Cloudian do. They provide object storage. Now, if you're not familiar with object storage, it's web-scale storage that's born in the clouds. I use Amazon as an example. It was Amazon's first product offering within AWS was their S3 platform in 2006, and that has become almost the de facto standard for cloud storage. The use of object, the use of the S3 API, and they've experienced huge growth. You can see it there, 102% year-on-year growth for S3. Over 5 trillion objects stored in it. The whole key to it is that it leverages an API and it enables the support of third-party platforms to plug into it and to drive use cases. Now, not everyone can leverage public cloud storage. Now, that might be for compliance reasons. It might be cost reasons. There's a number of factors that come into this, and not everyone can leverage Amazon or Azure and their blob or S3 storage to meet that need for supporting that growth. And that's where object comes in. So if you look at object in general, there are some key characteristics here. Data stored as objects, not files, not blocks. When you write an object, the object itself contains the data, the metadata, and an ID, so it can be located. Ultimately, there's no file system, neither is there RAID. In some cases, you can use replication, but ultimately, we like to leverage Erosion Coding instead. We believe it to be more efficient. It gives you 1.2, 1.3 overhead on the data rather than 5, as you would have today. So that's the most efficient mechanism for doing it. Ultimately, that approach gives us lower cost, lower footprint. Because we're leveraging software-defined, we can build that on standard x86 hardware. So there's no proprietary cost base, proprietary hardware costs involved delivering that infrastructure. Again, it drives the cost right down. By using Erosion Coding, we have much greater data availability and durability. Again, because it's x86 hardware and software-defined, ultimately it's easier to scale. We just add more disk, is a disk is a disk. So it gives us much greater opportunity there. Now, I'm going to take a quick comparison between Braden and Erosion Coding for those of you that may not be aware of the difference and how this helps to drive that benefit. But ultimately, if you look at a traditional RAID environment, file comes in, it's striped across a number of drives. There's a parity aspect depending on the RAID configuration. And if a drive fails, the data is reconstituted for the parity before another drive fails. So straightforward, well-known, been around forever. Typically, based on the rate of failure for disks, people compensate for that by making a second copy to give you, and that's where your localized resilience comes in. It's also where your geo-dispersed resilience comes in your third layer. So what happens if I lose an entire data center or two data centers or a region? Third copy comes in, off the tape. Again, we end up with 4x the amount of data that we need just to protect against disk failure. Erosion Coding takes a completely different approach to that. So it's actually built on the same technology, underlying technology that mobile phone masts and comms use. The data comes in, there's an algorithm that's applied, and that data is then dispersed in objects across a network of storage nodes. So that algorithm sets the properties for the data. So the number of fragments that you break that chunk of data up into, a read threshold and a write threshold. Ultimately, the amount of chunks out of the 9, in this case, that we need to reconstitute that data for read, and the number we require to reconstitute or make available for write operations. In this environment, in this example, we have 9 fragments. We have a read threshold of 5 and a write of 6. What that means is you can lose 4 of anything and still work. Fundamentally, you can lose 4 of anything and still read your data. You can lose 3 and still write. So that could be an entire data center. That could be 3 disks, 3 servers, whatever it might be. Those different nodes that you see in that diagram could be across 3 different geographies. The environment itself is self-healing, so when nodes come back online, they rebuild from the remaining data. And because we disperse across that storage network, it means, like I say, you could have that over multiple locations, multiple geographies. You can build the resilience out to whatever you need it to be, and ultimately it's much more available and scalable at lower footprint than a traditional infrastructure. That object storage platform, that S3 context, is what Cloudian deliver in your own data center. If you look at public clouds, you get all of these good things. Cloudian delivers all of those, but it does it in your own data center. So that can be delivered either in software only on any x86 flavor based on reference architectures. So whether it's Lenovo, Dell, HPE, doesn't matter. As long as the reference architecture for performance is met, really doesn't matter. Or on custom-built appliances that Cloudian provide themselves. A single 4U chassis takes 700 terabytes of usable storage. So huge amount of scale in there as well, even on the custom-built appliances. As you can imagine, that opens up the ability for organizations to really gain that cost benefit, the flexibility, the ability to write applications natively into objects, but in your own data center environment. So you can overcome the challenges of compliance, GDPR concerns, whatever it might be, and have that on-premise. Economically, in many cases, once you hit 400 terabytes and up, it tends to work out more economical to put it on-premise anyway. So, yeah. It is, and they are the only people that are 100% S3 compatible. So they provide an S3 guarantee. Ultimately, the key, and the reason this is important, is because object storage, whilst it's very clever in what it does, without the third-party applications to plug into it. So whether that's using it as a back-end target for long-term backups, for production file system, for enterprise vault, for whatever it might be, you need to be able to plug third-party organizations into that. The de facto standard, as I said earlier, for that integration is the S3 interface. So as a result, with Cloudian, what we're able to do is pretty much guarantee that any of these third-party applications will work against the Cloudian object store. So it gives us better scale in that sense, rather than something free. Also, as part of that, as I say, it's very quick to stand up the systems. We have great flexibility about how we can deliver that, and also ultimately we can drive that sort of public cloud pricing, but in the data center. And I've got an example of that. So, and we can using object storage in Cloudian as a platform. What we're doing is really, and I'm just going to touch on some of these now. These tend to be the core use cases that we see in our customer base. Archive and backup. So organizations that want to remove tape from the environment, for example, how do we get a low-cost alternative to tape that gives you my archive in a more accessible way? Well, object storage is a great way of doing that. Content repository for media content. It works very, very well for video, for call recording, for those sorts of media content. It's a very good place to store that at scale to give you the same protection but in lower footprint. Big data analytics. This is becoming more and more prevalent, as you can imagine. Ultimately, what we see here is that, if you use Spark or Hadoop or any of those things, you get sparingly. You run a job, that job runs for a period of time, the data is then effectively moved. What we see as a good use case for object is actually as that sort of long-term holding pen for the large amount of data that you're holding, to then move that data into the analytics platform. So application-wise, the ability to start writing applications natively over S3 is, again, a huge benefit. If you want to start using that for test and dev, for example, to develop your applications against S3 but without running it in public cloud and having that cost base run away with you. IoT, again, similarly to big data, how do we get a long-term repository? How do we get an environment to push that data back into that gives us scale? And the final one, which is probably one of the most beneficial, is global file system. So the ability to effectively centralize our file data into the object storage system and just distribute the content that you need to go to those remote offices when you need them. So that 20-30% of hot data that these sites need access to, well, why put a storage system in place to hold that entire data set when 70% of it is cold? This gives us a mechanism to streamline that, reduce that remote office footprint. The technology we use to push back into the object store have inherent snapshotting, so you can remove the need for localized backups and data protection, off-siting, tape, all of those sorts of things disappear. So a huge use case and a massive benefit for our customers in leveraging object storage as that back end. So for us, the next question is how do we get there? I mean, it's a new way of delivering this infrastructure, and ultimately finding the right use cases, building the TCO models, etc. is difficult when you don't understand your data. So as an organization, what Nephos has done is develop some front-end services here to, one, scan and understand the current data set, the current usage patterns, who's using what, when, why, how, what's cold, what's not, what's duplicate data, I always liken this to the moving house analogy. When you move house, you don't want to take all the old stuff with you. You want to put it in the skip. So ultimately, we leverage that service to identify those data sets. What we then do is basically build out an object as a platform model. So identifying use cases, opportunities to use object, identifying the cost model, creating the business case, build the TCO, etc. I'm going to give you a brief example of where we've done that before, which is, it's a financial services organisation running traditionally 350 terabytes worth of VNX infrastructure over 9 different locations. And what they're doing is effectively running data domain net backup to protect all of that environment. 100 terabytes of file, 250 terabytes of pop. What we're proposing, and the study that we did with them, was to identify the object use cases. What we're able to do is kind of push that 350 terabytes worth of usable storage down into 150 terabytes across 2 sites to give us the same level of protection and centralize all of that data. So immediately you can drop the footprint down in the data center, in support, pretty much straight away. What we then do is we use something called Braden in this environment to push out file services into those remote locations or into that Cloudian object store. And then we're leveraging technology from Rubrik to remove the data domain and the net backup environment and collapse that down into a next-gen backup platform. Again, in a separate logical bucket on the object store, but using that as our target for long-term data retention at lower cost. It enables us to remove tape, and it enables us to drive a whole heap of saving. 25% reduction in data center space, 50% less on operational overhead. We drop the initial investment on their refresh down by 27%, and ultimately reduce the overall cost in 3 years by 38%. Now, when you put that in real terms, that's 650. It's $1 million worth of saving in effect over 3 years. So that's the model that we take, and that's what leveraging technology like Cloudian enables us to do. So that's all I've got for you today. Hopefully that makes sense. I'm just going to take a quick check and see if there are any questions, but it doesn't look. So with that, if anyone has any questions, feel free to push them onto the chat. Try and answer them for you now. I'll give you a brief minute. If there's no questions, what we will do following this, share a folder with the slides from today and some collateral, some of the data sheet information from Cloudian and from ourselves to you guys after the call. But hopefully that was a worthwhile use of your time, and hopefully it provides some information. Got a question. Is Cloudian available as an appliance? The answer is yes. It can be delivered in 2 different appliance formats. There is a 1U appliance and a 4U appliance. You can mix and match those depending on design, really. So ultimately, we can deliver that as a single unified platform on premise. No need to buy your own hardware. So yes, that is absolutely possible. The model for that, by the way, is that you buy the appliance and you buy annualized or 3-year support with that thereafter. A bit like if you were buying a Cisco switch or a firewall or whatever. Any other questions? No? Okay. Well, in that case, so I have a question, another question, what tooling for integration with S3 data replication? So if you mean S3 public cloud, S3, Cloudian has a number of things. So depending on use case, as long as the third-party tool works over the S3 interface, there's no reason why it shouldn't work with Cloudian. They also have the ability to natively snapshot data out into WSS3, Google Compute, and Microsoft Azure. That exists today. So that gives us a couple of benefits. You can use that as either, if you want to keep a third copy, almost a worm-compliant copy in public cloud off-site, we're able to do that natively, and the management of that is all done through the Cloudian interface, so you don't need to manage anything else. We just point it at the cloud bucket. That gives us replication in that instance, which I think is what you're asking. From a deployment on-premise perspective, we can use replication instead of Erosion Coding. It's less efficient, but in smaller deployments, it tends to be what's used. So we also are able to replicate across multiple nodes, across multiple settings too. So we have some flexibility over it. We can also do that down at a bucket level. So within the Cloudian infrastructure, you're actually able to set, if you've got a different bucket for a different use case, there might be certain data sets that you want to push off into public cloud as a third copy or as worm-compliant copy. You might have some that you want to erase your code. You might have some that you want to replicate. You can mix and match those on that bucket level. Hopefully that answers that question. Any more? Anything else? I'll just give you a sec, just in case. No, it doesn't look like it. Okay, so, I mean, with that in mind, as I say, hopefully that was useful for you. One of the team will be in touch anyway. We will share the slides and some information with you that you can download at your leisure. And as I say, hopefully that was it for you. So thank you very much for your time today, and hopefully we'll speak again soon.
Yes, thank you.
Have a good day.